Okay, right. This is lecture 4. In lecture 3, we looked at a new interpretation of Hume as a sceptical realist. We looked at singularist theories of causation, which insist that causation is a force or a power or a necessary connection. We looked at Strawson's argument for the new interpretation. We looked at an ambiguity in the new interpretation, whether it should be empirical in the sense of real essence or in the sense of a functional definition. And we clarified the new interpretation. So I suggested that it couldn't be real essence and that it would be functional definition, but we're going to have another look at that. So in this lecture, we're going to have a recap on last week because I realised that 2 weeks is a very long time to remember anything. So we're going to have a quick look at Strawson's Hume. We're going to have a quick look at singularist theories of causation, and we're going to have a quick look at Strawson's argument for the singularist theory, or for the new interpretation of Hume. Then we're going to have a look at types of singularist theory, so types of empirical analysis of causation. We're going to have a look at problems for such analyses, and we're going to consider how philosophical analyses and philosophers work with empirical analyses and with scientists, because it's a reasonable question to say, well, if causation is going to be discovered by science, then what job do philosophers have? I mean, do philosophers have any role in the discovery of the nature of causation? And finally, we're going to end with a summary of where we are, because this is the last week I'm going to look at theories of causation. Next week, I'm going to look at causation and time. And the last week, I'm going to look at mental causation, so mental states causing actions and so on. Okay, so let's have a look at Strawson's Hume. Strawson says that Hume doesn't reduce causation to regularities. The knee-jerk or traditional interpretation of Hume says that Hume does do that. But Strawson says that he doesn't reduce causation to regularities, even those that give rise to counterfactual dependencies. In other words, lawful regularities are not where it's at for Strawson, or Strawson's Hume. Instead, he's a sceptical realist. He's a realist about causation. So Strawson's Hume does say that we can't know anything about necessary connection. So if you remember, he says that you cannot tell empirically whether something's necessary or not. So he's sceptical about our knowing anything about a necessary connection. But he doesn't say, according to Strawson, that there is no necessary connection. He's not an anti-realist when it comes to causation. So this is Strawson's Hume. So Strawson's Hume, the idea that he's sceptical about necessary connection, but that he admits the possibility of a necessary connection, introduces the possibility of a scientific account of causation, an empirical rather than a philosophical account of causation. So let's have a look at what that would be. An empirical or singularist account of causation would say that singular causal relations are more fundamental than causal regularities. So if you remember, we looked at Hume's billiard balls. So one billiard ball hits another billiard ball and the other billiard ball runs off. But Hume says there's no causation in that. There's only causation when we see a regularity of billiard balls hitting other billiard balls and the first billiard ball running off. So for Hume, regularities are more fundamental than the causal relation. So something we can talk about singular causes only because we can talk about regularities. But with Strawson's Hume, we can talk about causation in the single case, and they're more fundamental than regularities. So there's causation in the individual case. It's an intrinsic, not an extrinsic relation. So if we see the billiard ball hitting the other billiard ball, I thought I put some pens somewhere, Hume would say you have to see several of these in order to see causation, but the singularist says there's causation there already, not that we have to wait and see lots of different cases. Now, some singularists think that we can observe causation in the individual case. Now, Hume denies that one. Anscombe, for example, says that as we're slicing through the loaf with our knife, we can feel that the knife is causing the bread, or the pushing of the knife is causing the bread to be cut. Armstrong thinks that we are aware of causation when we act on the world, or indeed when the world acts on us. We're aware of causation. We observe causation in the single case. But other singularists agree with Hume that regularities are needed, but they're needed as evidence for causation. They're not needed for causation to exist. They're just needed as evidence for the singular relation that is causation. And some singularists accept the Mill-Ramsey-Lewis account of laws, which, if you remember, was nothing more than laws are those regularities that feature in our best, i.e. our strongest and our simplest theories of the world. But others offer a metaphysically robust account of laws. So Armstrong, for example, believes that laws are real gnomic necessities that hold between universals. So a universal is a property like redness. So it's not an individual instance of red, like my dress is red. It's redness, the universal that my dress partakes in, if you're a Plato. So you can have a metaphysically robust account of laws together with a metaphysically robust account of causation, or you can have a metaphysically robust account of causation but accept the austere account of laws. But the important thing about the singularist is that it allows causation in the individual case. It's an intrinsic relation. It's not a relation that comes from other things in the world. So just recap on an intrinsic relation. Any intrinsic relation is relation or property of mine is a property that I have whether anything else exists or not. Okay, it's a property that I have in myself. Whereas an extrinsic relation, somebody else must exist. So I can't be a daughter unless there's a mother or a father, or mother and a father. So that's an extrinsic relation. But being 5'6", I'd be that even if the rest of you were to completely disappear. So causation is there whether there's anything else or not in the individual case. Okay, so that's the nature of an empirical or singularist account of causation. Now let's have a look at some particular examples of empirical accounts of causation. Incidentally, I should just say before we look at these that as they're empirical accounts of causation, the most philosophers can do is gesture at them to say what they might be. Obviously, it's science who would establish that these are indeed cases of causation. So nobody's saying that these philosophers are what they're doing is suggesting that these are hypotheses as to what the causal relation might be. So Fair thinks that it's energy or momentum transfer. So when A causes B, there's a transfer of energy or a transfer of momentum between A and B. And Heathcote thinks that the cause event and the effect event are both composed of particles, and that when you have a causal relation between them, you've got an exchange of field quanta between these particles. Salmon thinks that when A causes B, a mark of some kind is transmitted from A to B. So there's got to be some structural alteration in B that is a result of A. Kistler thinks it's the transfer of a property. So A transfers a property to B if A is the cause of B. Dowell thinks it's a world line of objects exhibiting physical persistence. So I understand that a world line of objects is a point in space or a line of a point in space-time. The physicists amongst us here can tell me whether I'm right or wrong. But there's physical persistence of some kind between cause and effect. And Armstrong thinks it's real gnomic necessitation, that there's a relation of necessitation, but empirical necessitation, it's a contingent relation between cause and effect. Okay, so those are types of singularist theories of causation. Right, and common to all these, I thought the whole slide was going to change, but okay, common to all these accounts is that causation is a physical process transmitted from cause to effect. And the job of science is to find out what that physical process is. Okay, so Strawson, we're looking now, so we've had a quick look at Strawson's interpretation of Hume. We've had a quick look at what sort of account this would give, and some examples of this type of account. And now we're looking at Strawson's argument for these accounts of causation. So firstly, he thinks they hold the promise of solving the problems faced by the regularity theory of causation and the counterfactual theory of causation. So if you remember one, there was, we had Lucy threw a brick and it went through a window, and Brian threw a brick, and but it sailed through the window that had already been broken by Lucy's brick. But it did so quickly afterwards that actually it's problematic for RTC and CTC to say what it is that makes Lucy's brick the cause and not Brian's brick. Well, the singularist theory of causation has no problem with that. It just says that, well, there's a physical process that holds between the throwing of Lucy's brick and the shattering of the window, and there isn't one between Brian's brick and the shattering of the window. End of story, it's easy. And you can see why. Once you postulate a real physical process linking cause and effect, you can see that you don't have problems with the fact that there are cases of causation without counterfactual dependency. And Strawson also believes that the empirical account of causation avoids the absurdity of insisting that nothing explains the regularities we observe or the counterfactual dependencies that we postulate. So the thing about, and I remember being an undergraduate and first understanding, or at least I didn't think I thought I didn't understand Hume's theory because it seemed to me just daft. You know, how could you think that there's no more to causation than regularity? Surely the regularity must have an explanation. So I have quite a lot of sympathy with the idea that there's an absurdity involved in saying that there's nothing more, that the regularities are nothing more than a brute fact about our world, that there isn't anything that explains them further. So those are Strawson's two arguments for the singularist theory of causation. But of course, what he's doing is making a philosophical case for the existence of a scientific theory. He's not trying to put forward a scientific theory, because of course that's what scientists do. Okay, so there are two questions we ought to ask about this theory. Firstly, how likely is it that an empirical analysis of causation will tell us what we want to know, which is about the nature of causation? So if you remember, we're here in these lectures because we want to know what causation is. We've seen how important causation is for prediction and explanation and manipulation. We'd like to know what it is. We've had problems with philosophical accounts of causations, the RTC and the CTC, but how likely is it that science will come up with an analysis of causation? And secondly, we'd like to know, well, if they're successful, if science does come up with a philosophical analysis, does that mean that philosophers have no role to play? Have we shown, in effect, that this is another area where philosophers must just bow to science and hold back? Okay, so let's have a look at problems for the singularist theory of causation. And I'm going to look at several. Firstly, I'm going to look at are there physical processes that are both necessary and sufficient for causal relations? And see, we're still playing the philosophical game there a bit, but I'll say more about that in a minute. I'm going to ask what the relation is between the concept of causation in science and the concept of causation used by the folk, i.e. us. I'm going to look at whether there could be empirical evidence for gnomic necessities. So Armstrong claims that causation is gnomic necessity. So if that's put forward as an empirical theory, which it is, then there must be empirical evidence for it. I want to have a look at what that evidence might be. And we've got to be able to say, I mean, if we've got all these candidate hypotheses for a physical account of causation, then clearly we need to be able to say something about how we decide between them. How would we decide which empirical analysis of causation is correct? And finally, I suggested last week that if we think of causation as a functional concept, then we've got to look first at identifying the functional role of causation. Okay, so I'm going to look at each of these in turn. Okay, so, right, hang on. So I'm going to look at the first one first. This is a sort of last gasp of the philosophical account, because what the philosophers have been thinking over the last couple of weeks is that the analysis of causation is a question of an a priori problem. In other words, we can analyse it from our armchair. We don't have to get up and do any science. All we have to do is to decide what are the conditions necessary and the conditions sufficient for the application of this concept. And so the first objection, if you like, to singular theories of causation is if you like, a last gasp of that a priori analysis. So some people suggest that physical processes can't be sufficient for causation. So, for example, Pam throws her brick through the window while Tom watches in dismay or sprays purple paint in the air through which Pam's brick passes. So neither Tom's watching nor his paint spraying cause the window shattering, but both of them are physical processes. So clearly just being a physical process can't be sufficient for causation. This is a sort of yawn argument that I think discredits philosophy. I mean, who's saying that any physical process will do it? Nobody is. But I put this in just to show you how it fits in. So if you're still engaging in the a priori analysis and you still believe that therefore the concept of causation has necessary and sufficient conditions for application, then you're going to apply this to the empirical accounts. And it's certainly true, isn't it, that if we take Fair's claim, I've forgotten what Fair's claim was, but energy or momentum transfer. If there's energy or momentum transfer and no causation, that would be a black mark, wouldn't there? Wouldn't it, against energy transfer? But it doesn't seem to be a particular black mark against these theories because nobody's postulated these theories in the first place. Okay, so if we're going to talk about misconnection, we have to be looking at one of the theories that has been actually postulated. Okay, disconnection cases, on the other hand, suggest that no physical process is necessary for causation. Now, I have to admit, I don't understand this, so I've put it here in the hope that somebody can explain it to me. But the suggestion here is that there's a case of causation here, but there's no physical connection between cause and effect. So if I remember rightly, I was going to look this up before I came and I forgot. The catch is locked up, and when Pam releases it, this launches the catapult and the window shatters. but there's no physical process between Pam's releasing the catapult, which is already cocked, and the window shattering. Okay, does anyone understand that?
I disagree with it.
There
is a physical process.
Well, I can't see that there isn't.
Well, you haven't described everything. The catapult launches, that is, it goes into motion, it transfers energy, let's say, to the brick flies through the air, it hits the window shatters.
Yes,
so
but
there is a complete linkage of events.
Yes, but between Pam's releasing, I think the claim is between Pam's releasing the catch and the window shattering.
Well,
you have to reach for a counterfactual, don't you? Had she not released the catch, the window would not have shattered.
Probably.
And the thought is, but there's no physical... Anyway, I'm going to leave that with you. All I want to point out is, it's certainly true, isn't it, that if there's a case of causation without a case of energy or momentum transfer or something like that, then it looks as if this empirical account isn't good. So we can say, as far as we're concerned here, we may disagree with the actual examples given, but there is a point to asking the question.
Perhaps, I have never seen this experiment, this example before, but perhaps that they're very exercised with it. There is an intermediate. It isn't Pam who throws the brick. There is an intermediate. She does something with the catapult.
Oh, it's got to be more than that. Because if it was intermediate, we'd still have a causal chain, wouldn't we? Where you'll find that, I mean, all the references are as usual on the handout, and you'll be able to find that and look at it yourself. I can't explain it further because I don't understand it myself. Like Sean, I think, why isn't there a physical connection? Don't understand this. But anyway, if we're still playing the game of necessary and sufficient conditions, if we're still engaged in conceptual analysis, then we do have problems for certain physical processes. But, now I thought there was another slide here, but there obviously isn't, so let's... okay, necessary and sufficient conditions. There are different analyses of concepts. I mean, the classical structure of a concept is that to have a concept is to have a set of conditions necessary and sufficient for its application. And that's why conceptual analysis involves trying to find the conditions necessary and sufficient for the application. But in later years, or in more recent years, we've started to think, well, actually, not all concepts are classical concepts. Not all concepts have this structure of having necessary and sufficient conditions. For example, Wittgenstein points out that some concepts, the concept of a game, for example, are family resemblance concepts. So chess is a game, and so's tennis. Well, can we think of a set of applications that are both necessary and sufficient for bringing both chess and tennis and Candy Crush and think of whatever game you like, into the category of games? If you're starting to look for conditions that are necessary and sufficient for the application of the concept game, you're going to have serious trouble. And so what Wittgenstein suggests is that when you see members of the family, say that everyone on the front 2 rows or 3 rows is a member of the same family, you don't look like you, but you similar noses or something, and you've got similar eyes, and you've got similar height or gestures or something like that. And there's an overlapping of resemblances in a family. And maybe a concept is more like that. Or maybe a concept is more like a prototype. So we say, that's water. And so there's a hidden indexical component, as there is with the real essence of water. Well, if causation is a concept like that, we can see why there might be an empirical analysis, but not an analysis in terms of necessary and sufficient conditions. So For the necessary and sufficient condition analysis that we've been using so far to work, the concept of causation has got to be a classical concept. And we could have objected at any point in the first 2 weeks that actually causation isn't a classical concept. It's one of these other concepts. Okay, let's ask about the relation between the concept of causation in science and the concept of causation of the folk. Okay, if science is going to be looking for causation, one thing we might want to ask, our interest is in the nature of causation that the folk use. We're interested in the fact that we use causation to predict things, to explain things, to manipulate things. You know, we say that it was an ISIS bomb that brought down the Russian plane, that caused the Russian plane to explode, etc. So it's that sort of causation. And if we're going to have a scientific analysis of causation, what we'd like is the scientific concept to be at least related to the concept that the folk use. Well, that's okay, says, okay, is the scientific concept of causation the same as the folk concept of science? So Dow, for example, who's one of the people whose candidate empirical analysis we looked at earlier, says, well, yes, science doesn't use the concept of cause playfully. It's not using it in jest, nor does it offer a technical definition of causation. So the concept of cause in science is the same as the concept of cause that the folk use. Okay, maybe, but we might also think that the science improves on the everyday concept of causation, might we not? And the other thing we might ask is, which science should we look to for an empirical analysis of causation? And there are many different sciences. There's evolutionary biology, there's chemistry, there's nanotechnology, there's physics. Which one should we look to? And most people think, I don't know, most people seem to think that it's physics we should look to for an analysis of causation. So whereas evolutionary biology, for example, certainly talks about cause, and so does chemistry and so on, it's physics that we think is going to give us the concept of causation, at least judging by the people who've offered possible candidates. But there's a problem with this. One is, does physics even have a concept of causation? So, for example, the laws of physics that are used to do things like get rockets to the moon, etc., usually take the form of differential equations. And differential equations talk about a property of one object depending, or value of one variable having a value that's dependent on the value of another variable or other variables simultaneously, rather than beforehand. So the concept of causation implicit in physics is time reversible. So the laws of nature used by physics are talking about simultaneous causation, if they're talking about causation at all. Whereas surely the folk concept of causation has the cause coming before the effect. And if you remember, Hume writes that into the definition of cause. So if the folk causation, the causal concept of the folk, is time irreversible, and the causal concept of physics is time reversible, then why should we think they're the same concept at all? And similarly, the equations of physics are symmetrical. So we think that if A causes B, then B also causes A. Again, because of the reversibility of the equations. You can see that I'm talking beyond my real knowledge here. But we certainly don't think that with the folk theory of cause. With folk theory of cause, causes come before effects, and effects are the effect of causes. It's asymmetrical, not symmetrical. So we've got these two problems. If we're going to use physics for our analysis of causation, then physics must have a concept of cause, because otherwise, what are we looking at? And secondly, the concept of causation implicit in physics, if it's going to tell us, I mean, it might tell us something very interesting about the physical concept of cause, but if it's going to tell us anything about the folk concept of cause, then we've got a story to tell about reversibility and symmetry. So, okay. So I've looked at the first two questions, the could there be necessary and sufficient conditions? Moving on to the gnomic necessitation of Armstrong. Okay. Oh, hang on. That's right. Okay, Armstrong claims that causal relations are contingent relations of gnomic necessity between universals. Well, this seems to permit two things we'd really like it to permit. One is the multiple physical realization of causation, a strength of the functional theory that we examined last week. Do you remember when we looked at real essence, we saw that the implication of the real essence theory was that water is H2O. Science has discovered that water is H2O. So the claim water is H2O is an a posteriori necessity. Okay, it's a posteriori because science had to discover it, but it's necessary because if we travel to another world in which there's something that looks, tastes and feels and behaves like water, but isn't H2O, it isn't water. And that seemed to be a problem for the case of causation because we felt quite strongly that there could be different types of causation in different worlds. Well, if Armstrong is right, we can allow that because instead of being an a posteriori necessity, what we would have is a contingent necessity. So an idea of an something we can discover that isn't necessary across different worlds. So multiple physical realization of causation. But also, we can say that causation is the same thing in every possible world. So for example, in this world, we discover that underpinning the regularities that we observe and that we take to be evidence for causation are field quanta, say. But then we travel to another world and we find that underlying the regularities that seem to be causal, we find there's an exchange of momentum. Okay, but here we can say, if we insist on the real essence account of causation, that causation isn't, science discovers an a posteriori necessity, if they're field quanta in this world, they would have to be field quanta in every world, and therefore the exchange of momentum in this other possible world isn't causation. But Armstrong says, well, yes, it can be. Because what's important is not what the realizing relation is, but whether there's gnomic necessitation. Do you see? He seems to allow us to have both things. And if he does, this would be really nice. Because, for example, we'd find it very difficult if we went to Twin Earth and found something that looked exactly like water, behaved exactly like water, etc., we would be tempted to call it H2O, wouldn't we? But we couldn't call it H2O because science would have shown that it's not H2O.
If it behaves exactly like water, how would we know that it's not H2O?
Ah, yes. We'd have to say at a macro level it behaved exactly like water, because it couldn't behave exactly like water if it was not H2O at a micro level.
In such a case, the problem doesn't arise, surely.
This is a thought experiment, not a real experiment. We are allowed to do that. Okay, well, no, it would be perfectly reasonable. It would look exactly like water and taste exactly like water, and it would flow down hills and it would come from the sky.
And you would die without it, yes.
And you would die without
Except
it, perhaps.
You wouldn't, because because you don't need it, because it's not water. In your biochemistry of your body depends on that water
Yeah.
being H2O.
Okay, I'm not going to get involved in that sort of discussion. Okay, we're going. As we saw last week, I'm going to repeat myself here. The scientific discovery of the real essence of water means that anything with a molecular structure other than H2O is not water. However much, and this is where Mike disagrees with me, if it looks, tastes and behaves like water, says Mike, it would be H2O. And I'm saying if it isn't H2O, it's not water. So I'm saying a slightly different thing from Mike. But Mike is disagreeing with this final clause in my sentence.
It's the behaves that is the killer.
Yes, okay, not even the final clause, the final bit of the final clause. Okay. On the real essence story, science discovers an a posteriori necessity. On Armstrong's story, science discovers only contingent relations of gnomic necessity. Now, I have a bit of a problem with that. But suppose science discovers that the regularity in this world, realised by exchanges of field quanta, as Heathcote says, and suppose we travel to another possible world and discover that the regularities there are realised by transfers of energy, okay, as Dow says. To say that the regularities in this other world are causal, we'd have to know that they were realised by gnomic necessities as well as energy transfers, wouldn't we? Because if there aren't any gnomic necessities there, then there isn't any causation, is there? There's just regularity. Can I? Okay, listen, I'd like to get the argument out and then you can disagree with me. Is that all right? But it's very difficult to get an argument out when somebody's disagreeing as I'm giving it. Okay, so, the first thing is very easy, is it not? We can imagine that the regularities in this world are realised by exchanges of field quanta. And then we can also imagine this other possibility. We travel to another world and discover there the regularities are realised by transfers of energy. But what Armstrong is saying is that causation is not field quanta and it's not transfers of energy. It's gnomic necessity, relations of real gnomic necessity. That's why we can say that both of these are cases of causation, even though they're not the same thing. Okay, that's the apparent strength of Armstrong's theory. But to say that the regularities in the other world are causal, okay, so we're assuming that there's causation in this world, and science has discovered that it's realised by changes of field quanta. In the next world, we see that there are regularities, okay, that were they happening on this world, we'd say they were causal. And we discover those are realised by transfers of energy, okay? Now, to agree with Armstrong that they're both causation, we'd have to say that we know that the regularities in this world are causal, by definition, but are the regularities in that world causal? Well, if to be causal on Armstrong's idea, there'd have to be gnomic necessities. Well, okay, so how do we tell that they're gnomic necessities? I mean, how could we know this? How could we possibly know this? We know that they're regularities, but we don't know that they're necessary regularities. We can't see empirically that there's a modal truth here. So the two hypotheses are empirically equivalent. So every causal sequence instantiates a gnomic necessity, that's Armstrong's hypothesis, and every causal sequence instantiates an exceptionless enough to allow for probability regularity, i.e. the Humean theory. Well, if those two are empirically equivalent, then Hume is right, isn't he? We can't say, there's nothing empirical that could tell us that there was a necessity here. Okay, Mike, I'm afraid everyone's looking very askance at this. Okay. I'm just thinking about how to because now we've introduced the idea that we don't like this one. Should we discuss it now or should we discuss it later? Let's discuss each one now. So let's go back. Okay, let's have a look. Did you understand what I was saying when I said, okay, one problem for the STC would be this. Good. Let's say causation is energy transfer. One is energy, causation and no energy transfer. Two is there's energy transfer and no causation. Okay, so if you're postulating the claim that causation is energy transfer, okay, we're picking one of the candidate STCs and we're saying, okay, let's assume that one's correct. If we find that there's causation and no energy transfer, that would be a bad mark for that theory, would it not? Yep. Okay, and if we find energy transfer but no causation, that would again be a back mark for it, would it not? Okay. Now we could say here that this is going to be a probabilistic theory, so we could allow some cases of causation without energy transfer, some cases, but if there are too many, it's just going to be not runnable, isn't it? Are you going to disagree with?
Causation has no energy transfer, black mark. Energy transfer, no causation, no. They're not symmetrical. You can have causation must have energy transfer, or there's a black
If they're the same thing. Yep.
But that is, causation requires energy transfer. Energy transfer does not necessarily imply causation, because there might be other purposes for energy transfer. Okay,
I've put an identity here. And it's certainly true that we could say that there are energy transfers and other things. So that's it. If you're going to say it's identical to, then that would also be a black mark.
True, but not proven the second one.
Yeah, okay. So if we take out if we say reduces to, that becomes much less of a black mark. Yeah, accept that.
But there still is a black mark in the first one.
Yeah. Do you see the thought there? So if you're saying that causation either is identical to, is the very same thing as energy transfer, or you're saying causation reduces to energy transfer, then in the first case, if you find causation and no energy transfer, it's got to be false. But if you find energy transfer, no causation, there's a possibility that energy transfer is one form of causation, but that there are other forms. So that wouldn't be such a black mark. But you'd have to allow the possibility of there being other forms. Okay, everyone understand why that would be a problem for causation, even though the two examples that we gave were actually neither of them very convincing. Okay, do you accept that one? Bob?
My question would be, supposing you found they were absolutely equivalent in the sense that every single transfer of energy produced what we call a cause, and every single cause
Can you speak up?
accompanied by a transfer of energy. That would, to me, be an interesting scientific fact, but it wouldn't actually tell us what causation meant, because we'd have to know that in order to be able to establish that what I just said was true.
I agree with that, and I'm going to say something about that later on, so perhaps I can leave that to say it later on. Okay, everyone accept that that would be a problem. Okay, let's move on. The relation between the concept of causation in science and that of the folk. So if you remember here, I said firstly, What was the first thing I said?
Which science?
Oh, yes. No, the second one I said was which science are we going to look for, but the first one I said was what's the relation between the folk concept of causation and the scientific concept of causation? I mean, when evolutionary biologists talk about causation, do they mean the same thing as what the folk mean when we're talking about causation? We can give an argument for yes, we can give arguments for no. If we're going to say that the science is going to find an account of the nature of causation, we want there to be some claim that it's going to be yes. So you're looking at... So the question is the scientific concept of cause identical to the folk concept? And there are answers, there are yes arguments and there are no arguments. So Dow said yes, scientists don't use it playfully and they don't have a technical definition of it, so that's a yes argument. And I gave a no argument when I looked at the next question, was which science do we look to? People tend to look to physics. Well, if we're looking to physics, it looks as if the physical concept of cause is actually very unlike the folk concept of cause. And so even if we get a really good empirical account of the physical concept of cause, have we learnt anything at all about the folk concept of cause? That's the question. I mean, you might say it doesn't matter. The physical concept of cause is much more interesting than the folk concept of cause. So, you know, who cares if physics isn't giving us an account of the causal concept, the folk concept? Okay.
If a physicist explained to the folk what his concept was, then I would see the folk concept of causation developing and changing. So I don't see the folk concept as being in any sense static.
Okay.
The concept that would have been held 200 or 300 years ago is probably quite different to the concept that we currently hold.
Okay.
Folk.
Well, and that would be another argument for yes. So we can say even though the physical concept of cause looks at first glance very different from the folk concept, actually we can make another argument to say it is. But the problem I'm drawing attention to is the fact that we've got two concepts here which might actually be the same concept or might not. And if what we're after is an account of the folk concept of cause, the empirical account would have to be an account of the folk concept in order for it to be acceptable to us.
Because if you think pre-Newton, the folk concept of cause would be very much different and
Yeah.
would have changed by the ideas of Newton.
What I mean is we'd have to give a yes to the question that the science concept is the folk concept. Yeah, I know it is, yes, and that's why you're not arguing against what I'm saying. So we can say, well, hang on, the scientific concept of cause is of no interest to us when we're trying to analyse the folk concept. If that's true, if it's really true, then there's no empirical account of concept. On the other hand, we can surely tell some sort of story to the effect that it is, which is what Christopher's suggesting. And as long as we can, then that's not an objection. But it is something that we have to look at if we're asking the question whether an empirical account is a good account of causation. Okay, now this is the one that is causing the problems. Okay, could there be empirical evidence for nomic necessities? And let's go over this one again. And then, perhaps, Mike, you can explain what your problem with it is. Okay, so on Earth, science discovers that all regularities that we take as evidence for causation are realized by exchanges of field quanta. Okay, that's straightforward. Then we travel to Twin Earth. So it immediately becomes a thought experiment of kind. But we travel to Twin Earth, and science discovers that all the regularities that we, that we would take to be evidence of causation. So if we're on Twin Earth and we see a regularity like this, we say, oh, A's causing B, that sort of thing. But we find that they're realized by transfers of momentum. Okay, well, there are two possibilities. Either on Earth and on Twin Earth, they're both causation, they're both causal, but they're realized by different things. Now, it would be really nice to say that, wouldn't it? And what Armstrong is doing is he's giving us a way of saying that. He's saying that we can say that field quanta are, in the context of Earth, realizers of causation, and energy transfer or momentum transfers are, in the context of Twin Earth, causal regularities. And that's because both are gnomic necessities. In both cases, there's a real relation of gnomic necessity relating cause and effect, even though they're realized by different physical relations. Well, what I'm suggesting there is, okay, what we've got to do is say that we need empirical evidence. Okay, we've got the empirical evidence there because we know, don't we, that the regularities we see here are causal, because by definition they are. That's what causation is. Do we say the same thing there? It's only our intuitions that would say these are causal, isn't it? Why are these not regularities that are Humean regularities? The difference is that these must be, well, what Armstrong is suggesting is that there are modal, there's a modal impact both here and here, not the case that here and here they're Humean. Do you see the point? Okay, Mike, what's the problem with that?
There are two problems with that. One is contingent and one is much more fundamental. The contingent problem is that energy momentum transfers are mediated by quanta exchanges. There's no difference between the two cases. No. I said it was contingent, but it goes deeper than that. Looking at your original list of possible philosophical ideas what causation might be, it struck me that as far as I could see on a very quick glance, they were all reducible to the same physics underneath it. In fact, they were talking about the same things from slightly different point of view, from slightly different level. So that's the contingent problem. They're more difficult.
Okay, that's not an interesting problem from a philosophical point of view. You accept that?
It is interesting in the sense that if it is true, then nobody has suggested an alternative.
There's only one theory.
Exactly.
Yep. Okay, do people understand that? What Mike's saying is that all the apparently different theories that I gave initially all come to the same thing. That may be true, but even if it does, all that means is we've only got one hypothesis instead of the 5 or whatever that I gave.
But
okay.
There is a more fundamental problem, and that is insofar as now we are talking about physical explanation of causation, we cannot just talk about possible worlds other than physically possible worlds.
Well, we are talking about physically possible worlds.
Except that we are not. Once you start talking about H2O being, water being not H2O, for example, I was objecting to the behavior. Well, behavior, even on the macro level, I pass electricity through water, it decomposes into hydrogen and oxygen. The spirit of water on the other world would have to do the same, because otherwise it wouldn't behave the same. In other words, what I'm saying is that Armstrong said the contradiction you're trying to present here is, according to physics, physically impossible. And therefore, possible worlds just don't come into it, because all possible worlds will satisfy physically possible.
Okay, so you're saying that if water is H2O, then
If it isn't H2O,
nothing that... Oh, no, hang on.
no, that water must be H2O because no other substance can behave exactly like H2O in all circumstances. That is not physically possible according to our best theory.
Okay, so if water is H2O, then nothing else can look, taste,
Oh, look,
and in
taste,
particular
yes,
behave
it's the behavior that's circular.
like water. So it couldn't be water,
Yeah.
is what you're saying. Okay, so you're rejecting the whole twin Earth thought experiment.
No. A twin Earth experiment is fine, provided you don't stick to physically possible worlds. But here we must stick to physically possible worlds because we are talking about physical explanations.
Okay, I think I've got an answer to that, but it's very difficult to think about it here and now. Let me think about that as I continue going.
I think there is an answer. There is an answer in the other physical world. What passes as water for us, which has the atomic number, whatever it would have, is slightly different on that world. That world is developed with slightly different isotopes. And in fact, instead of just being H2O, it's now H2 something else, O, which makes it
Well, the thought...
atomically slightly different, but it behaves identical to the way water does on this world. And that's possible, but very unlikely.
The original thought experiment was this. On Earth, you've got Oscar, who's looking at a glass of water, of H2O. And on Twin Earth, you've got Oscar, who's looking at a glass of XYZ. Now, both of them are, this one's saying that's water, and thinking that's water. And Twin Oscar is also thinking that's water, saying that's water. So they're identical with respect to their phenomenological states. In other words, everything seems to them exactly the same. Their behavioral dispositions are the same. Now, that is one that Mike is going to have a problem with in a minute.
No.
And their neurophysiology is the same. This is the thought experiment. Now, you'd have to, if you had that pre the Dalton's discovery of, who discovered that water was H2O? Dalton, I think, but I can't remember when. Anyway, if you had that before, so there's nobody on Earth who knew that water was H2O. The question is that you ask in the thought experiment is, do these two mean the same thing by that? Now, if you think that a concept is a human thing, that what determines the reference of a concept is how we would use that concept. In other words, what we'd see or touch or taste or feel or so on that would cause us to apply the concept, our behavioural dispositions with respect to the concept, and the way our brains behave with respect to the concept, then as these are identical, they'd have to have the same meaning. But if you say the meaning is determined by something outside, something external, they can't have the same meaning, can they?
I have no problem with that because I do not believe that it's determined by anything external. It's as simple as that.
Okay, so you don't think it's externally determined. You think all concepts must be determined.
Meaning is a human-made thing.
Okay. I think I'm going to agree with you in the end. So why don't I continue? The thing... Well, no, what's important is that you see the problem for this. So going back to what I said originally, okay, so forget Mike's first objection because that's, I mean, by his own admission, uninteresting, so it might just confuse you. No, it's not important. Okay. So on Earth, science discovers that all regularities are realized by field quanta. And on twin Earth, science discovers that all regularities are exchanged by, are momentum transfers. And forget the fact that they're the same thing, if they are. What Armstrong is saying is that both of these can be, whereas if we're going to go along with the twin Earth thought experiment, we'd have to say that do you know, I should have put my last objection first. I'm going to put my last objection, then come back to this one. Don't worry, I will explain it to you. Can I do that? Yeah. You're not getting hopelessly confused by this? Okay. I want to talk about how we're going to decide that empirical analyses of causation are correct. And I'm going to go on to, and this is quicker. Okay, so this is the final objection that I put down, which is how do we decide whether empirical analyses of causation are correct? I listed above many candidates, or at least I thought there were many candidates for empirical analyses of causation, and I might have listed many more. There are lots of people out there, a lot of them are physicists actually, also philosophers, who think they are different. If we're to adopt an empirical account of causation, and there are different hypotheses, so two things there, if there are different hypotheses and we want to adopt one of them, we have to be able to say which one is correct, don't we? We have to be able to give some claim. And this is importantly not an empirical decision, and I suspect Mike would agree with this. Okay. Imagine that we're deciding between two different claims. This is on Earth now, we're not talking about any thought experiment like that. Each candidate theory would have to make different predictions about what would be observed in different situations. So in order for them to be different hypotheses, they've got to make different predictions about what's going to happen in certain different situations. And we'd either have to try and create, or we'd have to try and observe these different situations. And what we'd be hoping for one in which field quanta are exchanged, but no mark is transmitted, for example, or vice versa. Okay, let's imagine there are such situations and that we can observe them or create them. It's still necessary to decide whether causation is present in these situations, wouldn't it? So we see that field quanta are being exchanged, but the marks are not being transferred. But is there causation here? Because if there isn't, then the mark transmission theory might still be correct. If it is, then the mark transmission theory isn't correct, is it? So it's our intuitions about what counts as causal that are actually the deciding feature. So I can see some people nodding and I can see other people looking very perplexed. So let me see if I can make that a bit clearer. So two hypotheses, okay, different hypotheses, two different sets of predictions in, I identical situations. Okay, that's what we want in order for it to be empirically testable, don't we? So we want one situation in which, so let's say two different sets of predictions, so set 1 and set 2 in the identical situation. So one situation in which set 1 are true and set 2 are not. Okay, well, how is the fact there's okay, there aren't any mark transmissions in this situation. The question is there causation in this situation? If you've already decided that causation is mark transmission, then if there isn't any mark transmission, you're going to say it's not causal. And if you've already decided that it's field quanta, then if there isn't any, if there is field quanta being exchanged, you're going to say yes. But actually, it's what we want to know here is this situation a situation in which there's causation? And the only thing that can tell us that is our own intuitions about whether this is a causal situation or not. Science cannot tell us that, because science is trying to tell us what causation is, but it can only do that if we already know what causation is to some extent. So the only way we can tell whether there's causation present is by using our intuition. And it's quite, intuitions about the proper applications of our concepts frequently play a part in decisions about the correctness of scientific theories. So, for example, in 1900 and 1934, Bohr came up with two different accounts of the electron. They were different because in the 1900 theory, electrons had a trajectory, and in the 1934 theory, they didn't have a trajectory. But it was decided that they're the same thing. So we had there a situation in which it was decided that instead of saying that the 1900 theory was wrong, we had shown in the 1934 theory that electrons didn't exist. Instead, we decided that actually the 1934 theory was a successor to the 1900 theory. It's just that in 1900 we had some false beliefs about electrons, not that electrons didn't exist. The beliefs weren't so false that we were prepared to say electrons didn't exist. And we decided, on the other hand, that phlogiston didn't exist. We didn't say that it's the same thing as valence electrons, for example. So here we decided that something did exist, we just had false beliefs about it. Here we decided that our beliefs were so false that it didn't exist. And that's a decision that we have to make about how you apply the concept, not itself an empirical decision. So decisions about identification and therefore reduction are, in the final analysis, philosophical decisions. So, for example, if somebody says that pain is C-fibre firing or something like that, we've still got to say, well, okay, we can use that as an instrumental definition, but are we going to say it's the same thing? That's a philosophical decision. And I'm not saying for 1 minute that empirical evidence doesn't play a crucial role. I mean, it's empirical evidence that provides us with likely candidates, as with here. We've got different sets of predictions. But when we're trying to decide between the two different sets of predictions, we've got to use our intuition about what causation is, about what pain is, etc. So philosophers are going to, and the final problem I was going to look at was who tells us what the functional definition of causation is. Okay, and I'm going to say that philosophers are going to help identify the functional role of our causal concept, because actually that's what we've been doing in doing conceptual analysis, is looking at the role that our concepts play in our inferences. So we look at what licenses a causal claim. We see a regularity, and this licenses us to say that A causes B. We also look at what causal claims will license. So if smoking causes cancer, then that licenses the decision to give up smoking because you want to be healthy or something like that. So that's looking at the inferential role that causation plays in our causal theories. And yeah, I've just said that. And there are empirical sciences, I mentioned them right at the beginning, robotics, any science that looks at our thinking about causation, that tries to determine what the empirical evidence is that we look to decide whether something's a cause or not, will also have an important role to play in the identification of the functional role of our concept. So, okay, my claim is that there are still jobs for philosophers, even if there is an empirical analysis of causation, and nothing I've said suggests that there isn't, that there couldn't be. On the contrary, I'm quite pro the idea that there's an empirical analysis. Philosophers still ask of every relation suggested whether it's necessary and or sufficient. That may or may not be interesting. I disagree with Mike. I do think that we should identify analyses that have modal implications and that aren't, therefore, empirical claims at all. I think that Armstrong's claim is empirically equivalent to the regularity theory of causation, and therefore that it isn't an empirical theory. I think philosophers have a job in comparing empirical causal concepts, for example, the causal concept that's used in physics, to the folk concept of causation, and therefore saying whether this is indeed an account of our folk concept. Deciding whether an empirical account of causation is correct, I suspect that's, and this is something I'd like to think about more, I suspect that that's actually coming in the disagreement that Mike and I were having, if we were having a disagreement. And I think philosophers also help to identify. They help, they don't just do it, because there are sciences that also look at the application of our folk concept of causation. So still plenty of jobs for philosophers, even if there is an empirical account of causation. Okay, so we've looked at, okay, this is where we are now at the end of the 4th lecture. Next week I'm going to go on to causation time, and then causation and the mental. But so far we've considered 3 types of reductive analysis of causation. So we've looked at the regularity theory of causation, the Humean theory of causation, according to which causation is lawful regularity. And that's an a priori, a philosophical theory. We've looked at the counterfactual theory of causation, where causation is counterfactual dependencies of some kind. And if you remember, we saw that you have to add that there are chains of counterfactual causation and so on. And again, that's an a priori theory. It's a philosophical analysis. Then we've looked at the singularist theory of causation, where the claim is that causation is either a physical process or a set of physical processes. So that's not an empirical, not a philosophical analysis. That would be a scientific analysis, an empirical analysis. But I've argued that there are plenty of jobs for philosophers in deciding whether any such theory is correct. We've not considered either primitivism. Do you remember I said right at the very beginning, by analysing the concept of causation, we're hoping to either reduce it, show that it's primitive, that it's so fundamental and so central to our thinking, it can't be reduced at all, either empirically or philosophically. So that might be like the idea of truth, for example, is arguably a primitive concept. We haven't looked at eliminativism, the idea that causation doesn't exist. So, for example, Russell thinks that causation doesn't exist. He thinks that physics has shown that. And the reason he thinks that physics has shown that is because physics never mentions the word cause. And there's quite a nice quotation in your handout, so you can have a look at that. Okay, so that's what I've done, although I think that we've got so tied up in it. I hope you see the structure here. I explained how Strawson's Hume was different from the traditional Hume, what the singularist theory of causation was, Strawson's argument for the singularist theory, which, if you remember, was it improves on the regularity theory and the other one, and that it explains regularity. It doesn't just insist they're brute. We looked at types of STC, which is, if Mike is right, are all the same type. We looked at problems for the singularist theory of causation. We looked at several different ones. And I argued that even if the empirical theory is the correct one, that doesn't mean there isn't plenty of work for philosophers to do in finding it. Okay, and I've summarised where we are, and next week we're going to consider that. And we've got 10 minutes for questions. Good. Chris?
You were talking earlier on about, was it disconnection?
Yes,
Your
when I
earlier
was...
slide. Now, is this where you consider the possibility that there's an effect without a cause?
No, this is a case where there's a cause and an effect, but no physical process linking the two. So disconnection was that catapult one that I gave. Disconnection, the idea is that there is causation, but no physical process.
Does that come down to the same thing? Of looking for, or apparently seeing an effect that you can't see a cause for?
No,
There is a
it's that you would say that A causes B, but there's no physical process
Okay, so there's no.
linking A and B.
Okay.
In which case, if you really have got cause, but you haven't got a physical process, then the thought is that causation can't be a physical process, at least in this case. That's disconnection. You had a question.
Yeah, well, I was going to say that I've lost track or lost to the discussion today.
Sorry about that.
Yeah, that's probably me. And I think it comes down to a question of definitions. It seems to me that what we mean by cause or causation is drifting around. And for that reason, it's difficult to pin down an argument. But it was particularly evident when you were talking about water in different worlds, or water perceived, observed by different people, and whether a given set of observable facts which cause each of these observers to say, yes, that's water,
Yep.
might actually relate to something which, at a deeper level, isn't. But those two things are different. I would argue that if, in fact, at a deeper level they're different, then it's simply that one hasn't observed sufficient phenomena to be able to distinguish the differences between them.
Yep, absolutely.
So then the question of causation, are we going to say that we're observing the same thing? It depends whether we're focusing purely on the observer or purely on the issue itself. And therefore, we've got to be absolutely clear what we mean by causation.
I couldn't agree more.
And I'm not clear.
Yep.
And the more we go on, the more confused I'm getting.
Don't worry, I understand that. You're absolutely right. I mean, the fact, if I were to utter a sentence now, I'm going to say in Russian, but I know there's at least one Russian person in this room. But if that person shuts up, if I utter a sentence in Russian and then say, well, is it true? You're all going to say, reasonably enough, I haven't got the foggiest idea. Because in order to determine the truth of a sentence or the falsehood of a sentence, you've got to know what it means, don't you? I mean, that's writing large what the problem is that you're identifying. What you're saying is that what we mean by cause is drifting around in your words. And if that's so, then we're guilty of equivocation. If we're using cause in one meaning in 1 minute and one meaning in the other minute without realizing we're doing that, then we're guilty of equivocation and nothing we say is of any use. On the other hand, if one of the things that we're trying to work out in saying what is the nature of causation is what does causation mean, which it is, then it's not surprising it's drifting around, because what we're doing is we're trying out different hypotheses. And one of the reasons that it becomes so difficult is that in trying to square the philosophical question, what does causation mean, with the scientific question, what is causation, it looks as if we might be equivocating, which is why you get the feeling that there's sleight of hand going on. But actually what we're doing is we've got two different, what does causation mean? And what is causation? Do you remember right at the beginning, I said that there are semantic issues and there are ontological issues, and the two have got to go together. We can't say what causation is until we know what causation means. And arguably, it's also true that we can't say what causation means until we have some idea of what causation is. And one of the reasons we start looking at logical situations, at thought experiments as well as empirical experiments, is the twin earth thought experiment is precisely an experiment that's designed to pull apart our intuition about meaning. So some people think, and Mike is obviously one of them, that meaning is determined by properties intrinsic to human subjects. In other words, you might think, well, hang on, meanings, that's our business, isn't it? You know, we decide what the meaning of a word is. So properties intrinsic to us. Do you remember the difference between intrinsic properties and extrinsic properties? If that's true, if we've got two intrinsically identical twins, then the meaning of water should be identical as well, shouldn't it? And the twin earth thought experiment suggests that the meaning differs, and that therefore meaning cannot be determined by intrinsic properties. It's also determined by the world. So our word water is not it's not that we decide what counts as evidence for water, what water looks like, it's that the world also decides what counts. And one answer, you might come to this, you might say that the meaning of water is actually X, Y, Z and H2O. Okay, you've got a disjunctive theory of water here. So one possibility is that water is H2O, not XYZ. Another is that, and that's your, you were saying we just haven't seen enough yet. So we discover that all instances of water on Earth are H2O, but that actually what we didn't realise is that there are different types of water. There's XYZ as well. We could decide that, is what you're saying, is it not? Not you, him.
Quite. Actually, you're bringing to mind the recent discussion about whether Pluto is a planet or not. It's the same sort of territory, isn't it? It's a question of where...
What a planet is.
Yes, the question of you've got to decide what you mean by this.
Mm-hmm.
I mean, in the case of a molecule, it's much more simple than in the case of a planet, but the same principles apply. You have to decide, I think, what you mean by something.
But that applies to
Yeah,
any word,
but
like beauty.
that's what we're doing, isn't it? I mean, what we're doing is we're giving, we might think that it's obvious that the meaning of water is determined by intrinsic properties. Here's a thought experiment that makes it look as if it's not determined by intrinsic properties. Here's a reply to that thought experiment that says, no, we're wrong about that. We're still determined by intrinsic properties. It's just that we've got to allow that there are different situations that feed into the intrinsic properties. So what we're doing is expanding the behavioural dispositions that we allow to include X, Y, Z in the copy of water. I mean, the determination of meaning, do you see that if we're going to determine identity, that A is B, this relation of identity and reduction, one sort of reduction is an identity, we've got to know what both A and B are. So meaning, decisions about meaning are going to come into it as well as decisions about what happens in the world. So you're absolutely right, the meaning is drifting around. And what you've got to do if you want to do philosophy well is get to grips with how it is drifting around. I mean, I'm going to enjoy going home tonight and actually working out how the objection to Armstrong that I've given relates to the fifth objection that I gave, because I think I haven't thought seriously enough about that. I thought I had, but I don't think I have now. There was Mike and then Bob and then Dot. Mike.
You mentioned Russell with his belief that physics doesn't talk about causality, causation. That is actually not true, because causation is extremely important in relativity theory. And in effect, it gives an example which seems to be absent from all of this discussion, how science can affect our notion of causation not in a positive way, but in a negative way. It can tell us what causation isn't and cannot be.
Mm-hmm.
And specifically...
And cannot be.
And cannot be. So according to our best theories, there's a caveat of
okay.
this. Well, of necessity, because that's the only way we can know about the world. So currently, according to our best theories, any account of causation must somehow preclude causation without information exchange.
Mm-hmm.
Okay? To the point where some physicists actually saying, yeah, all of these possibilities that you've listed, etc., at the bottom, they are information exchange. Okay?
Yep,
So
okay.
in other words, it does give us information without saying what it is, but it tells us what
But
it
it
is.
says, yes, okay. Well, that would be right, because I mean, Lewis, for example, would say that the thing about logical possible worlds is there's no information exchange between them, and therefore no causation between them.
That is the problem with the Earth experiment, exactly, because there you are assuming that the two worlds are not accessible to each other.
Yes,
Because
but that's what
the moment they are, you would discover the difference in behavior.
Yes, but no, I'll have to talk to you about thought experiments, because thought experiments are constrained by the laws of logic, not by the laws of
They
physics.
are also constrained by their assumptions. And insofar as here you are talking about physical theories, you have to assume physical theories underlying.
Okay, we'll obviously have to discuss that. Bob?
I'm worried about water If we were having this discussion 500 years ago,
Before we knew water was H2O.
we might be wondering, I wonder what this stuff water really is.
Mhm.
And somebody say, well, we might discover, for instance, that it consists of two atoms and something, of one thing and an atom of something else. And then someone else said, we might go to another planet and find something just like water, which is a different consistency. And I think we would unanimously agree that that would not be water.
Oh,
I don't think...
oh, so I was expecting you to say the other.
No, I think if we decided that one day we'd find that water actually consisted of something, that's water, that would be water. Which is why I don't find causation parallel to water at all. Causation
Okay.
gets me up here.
Well, I completely agree with you that causation isn't like water, and I agree with you because I think water has a real essence. Yeah, so I would agree with that.
I suppose I was just going to add on to that, just thinking about the meaning of things, and you were saying, well, I was just thinking, your postulate of the planet. I mean, there are planets where liquid methane or something takes over the role of water in the atmosphere, in lakes, in oceans, and to a creature that grows up on that planet, they might call methane water because it has the same properties. It comes down from the sky, it gives them life, they presumably drink methane, liquid methane to survive. Their bodies are made of 80% methane, whatever, you could choose any substance that liquefies, solidifies, and has a large presence on various planets as an example, and that would be for them water. Now, because water is just an arbitrary word we just use to describe something which is liquid, which we can drink, and which falls from the sky and lands and freezes and does this and that. If your majority substance is not H2O but is another thing, you might have the same concept. Water, this liquid thing, this life-sustaining property, but it could actually refer to something completely different without
Yep.
being any...
It could be that some students of chemistry are bored stiff one day, they live in Cheshire, and they decide to test the water. And lo, it's XYZ. This is most peculiar. I mean, at that point, I think we probably would say water is H2O
I guess I'm just saying...
or XYZ.
Yeah, it's just... it's
But if it's not, if every instance of water in this world is H2O,
yeah.
I mean, what we're doing here is saying that if XYZ is on twin Earth rather than on Earth, then you're saying it doesn't count as water. But you're saying it could still count as water. So you're going for a disjunctive theory, even if it's across different worlds.
Yeah, because to me,
Yep.
a word, concept, and a physical thing is just what we attach onto something. So, we could use the word table to talk about four-legged things that we put stuff on, but we could equally, that four-legged thing we put things on could be an animal, or it could be,
Yep. Well, you're a Cartesian, believe it or not.
I'll move away from splod, which actually is the Venusian word for water,
Splod, right.
because we don't call it water on Venus. Your chain on slide 11, of the lady and the catapult and
Oh, yeah.
things like that, because you had a sort of conclusion somewhere on the line that there does not need to be a physical link between a...
Well, that's what this is supposed to this one.
Indeed. But you
Yep.
also raised the matter about whether it was necessary and or sufficient in an argument. And if you look to any of those things, you could look at any of those activities and say, is it necessary for that activity to take place in order for the window to shatter? And the answer would be, in that case, yes. You could not have the window shatter unless pan released, the catch was raised, etc. But if you just took one of those and just had one working and all the others switched off, if you like, the window wouldn't shatter. So one is not sufficient. Every single one is necessary.
Yeah, absolutely right.
You've got now an actual linkage between anything in that network of activity.
Well, do be careful here, because if you remember, we've seen that to talk about the cause is nonsense, always nonsense, and we talk about the cause when we're actually thinking about explanation rather than causation.
I don't mean to make it singular. All contribute to the cause.
Okay, but in that case, you're thinking if and I tend to agree with you. But if there's no physical relation between Pam's releasing the catch and the window shattering, then there may be a counterfactual dependency.
I'd go on to that separately, but there doesn't have to be a physical relationship,
well,
it has to be an operational relationship.
Well, hang on. If there doesn't have to be a physical relationship, then that, I mean, if there's no physical relationship between that, then, and yet that is the cause of that, then causation must be counterfactual dependency, not physical process.
I thought counterfactual had an if in it, which means it's probabilistic.
Well, even if it's probabilistic, that's irrelevant. If there's no physical process between that and that, but there is a causal relationship, then causation has to be analysed along the lines of counterfactual dependency or regularity theory.
I have to read my notes on that, because I made notes at the time. I'll go back to that. But there's
Okay.
still a relationship, whatever that relationship may be, between
Well,
Pam releasing the catapult's catch and the window shattering.
yeah, and the relationship is causal.
Which, if Pam did not release, would not allow the window
Yeah.
to shatter.
Well, we know that there's a causal relationship because we're assuming that.
Physical.
What we're trying to do is find a causal relationship without a physical process. I mean, I don't know whether this has succeeded or not, but if that causes that, but there's no physical process between that and that, then what we've shown is there is a causal process without a physical process.
Then I suppose Pam could say, it weren't me, Gov, nothing to do with me, honestly.
Well, no.
The policeman was-
No, what it would show is that causation isn't a physical relationship, but it is a counterfactual dependency, because as you rightly pointed out, it's certainly true that had Pam not released the catch, the window would not have shattered.
I'll try that before.
But this is not an objection to the counterfactual theory of causation.
No.
This is an objection to the empirical theory of causation, or that's what the thought is.
I think you're going to sign
But
blue.
there is a physical process there.
Well, yeah, but that's what I don't understand either.
It's
But
contained in the word catapult. It has-
well, no, it's this, the catch is up and it's,
Well, apart from that, there's still...
look, everyone's leaving and we're going to have to finish because I ought to be leaving as well. My cat's suffering.
Yeah, but there's obviously
Okay, thank you everyone. The handouts are here.